Greetings, ladies and gentlemen, and welcome to our second video on finding area of composite figures, where we're going to do some real life application type stuff. And we're just going to continue this time finding the area of the shaded region. So this might be a concrete ring that has to be, we want to know how much area is on the surface of this. So we recognize that we have a larger circle, and then inside of it a smaller circle that we're going to have to subtract out. So we're going to take the larger and we're going to subtract the smaller. So let's do the larger circle first. And we say that, hey, that's area is equal to pi times the radius squared. And we can see that the radius of the larger circle is 18 centimeters. So 3.14 times 18 squared. And when you do that math, you get 1,017.36. And of course, that would be centimeters squared. We'll put that on at the end. And now we want to subtract from that the smaller circle. So we have to figure out what is the radius of the smaller circle. So we're going to go area times pi r squared. And what is the radius of the smaller circle? Well, we can see that it goes to here. And so we're going to cut it off there. But that doesn't help us until we look over here and see that the shaded part is 8 centimeters. So we take the 18 minus the 8. And we find out that the radius of the smaller circle is 10. So now we can go 3.14 times 10 squared. And when we do that math, we end up with 314. So when we subtract them both, 1,017.36 minus 314, we get 703.36, and that would be centimeters squared for the area of the shaded region. Moving right along, we have another shaded region. We can see that we have a square, and they've taken out of it a semicircle. So we're going to subtract again, and I'm going to say that it's the square minus the semicircle. And so I'm going to start off with the square, and I can see the square has side lengths of 4 by 4, and area of a square is base times height, which is 4 times 4. Well, that's 16. And we're going to subtract from that the semicircle. Well, a semicircle is pi r squared, and we're going to divide that by 2 because we only want half of it. And so we have to calculate that if this side here is 4, the opposite side is 4, and so that the radius, that would be 2. So we're going to come over here, we're going to go 3.14 times the radius 2 squared, and divide that all by 2. And of course, you're plugging that into your calculator, and you get 6.28. And when you subtract that out, you end up with 9.72. And that would be feet squared for the area of the shaded region in that figure. And so you notice there I named them. I named the shapes in the first two examples. In this one, they're all pretty similar. And we're going to have to do a couple things. So I'm actually going to number them. I'm going to divide this up into two shapes. I'm going to go right here, and I'm going to have this first one, which is a rectangle, the second one, which is a rectangle. I have to take shape 1 and add it to shape 2. And then from that, I am going to subtract shape 3. Okay, so let's do the first two. And shape 1, I have a 5 here, and I got to find this side length, which would be 10 minus 7, so that means that one is 3. So this first one, to find the area, which is base times height, and that's 5 times 3, and that gives me 15 centimeters squared. I go to the second one, I can see I have the two measurements right here, so that's going to be 3 times 7, because again, area for that rectangle is base times height. 3 times 7, that's 21. So when I add those two together, I'm going to get 36. And then I'm going to subtract from that the area of this smaller one, which for number 3, that's a 2 by 2. Area again is base times height, which is 2 times 2, which is 4. So I'm going to subtract 4 from that, and I get 32, and again, centimeters squared for the shaded region. So it's just identifying your regions, figuring out how do you want to break it up, adding when you have to, subtracting when you have to, and coming up with the total area. Let's do some real life application. Here we have a deck. with a pool or a, I don't know, hot tub or something. And I see that there's three shapes. And I'm, interestingly enough, if you want to find the total area of the pool and the deck, I'm going to actually do a triangle, call that shape 1. I'm going to do a square, I'm going to call that shape 2. And I'm going to do a semicircle and call that shape 3. And there's one thing we should already know, and I forgot to put it in here when I do it up. This is a right angle, which is very important. So for shape 1, our triangle, we know that area for a triangle is base times height divided by 2. We know the base and the height have to be perpendicular, so we have to know that that right angle does exist there. So the base and the height would be 10 and 24, and dividing that by 2. And when we do that math, 10 times 24 divided by 2, that gives us 120. And then we go to the square. It's a really big square, 26 by 26. So I'm going to go to here to the square, and that's base times height to get the area. And that's 26 times 26, which gives me a big number, 676. I'm going to add those together. And then I'm going to go to my last shape, which now would only be a semicircle. I'm not going to include the whole entire purple circle because I included half of the circle inside that square of that part of the deck. And so I'm just going to do the semicircular part, and that's okay. We could do it either way. And so you get the area is pi times the radius squared divided by 2, 3.14. Well, if the diameter is 26, the radius is 13, so we're going to multiply that by 13 squared, and we're going to divide the whole thing by 2. And when you do all that math, you get 265.33, and we're going to add all three of those together right there, probably using a calculator, although we could do it by hand, and we get a total score for the area of 1,061.33 feet squared. So that's a real life application if you have a deck and a hot tub or a pool in the backyard. Lastly, we're going to find the area of the garden, and I see two shapes. One of them I'm going to double. So I have my first shape. Here's a square here, and there's a square there, so I'm going to add them together. In other words, I'm going to multiply those squares times 2. And then I have the section, as we learned the other day, the sector of the garden is part of a circle. It's 1/4 of a circle. And so that's going to be shape 2. And so let's just get right to it. For shape number 1, that's base times, oops, don't use a capital B, don't use it. That's base times height. And I am going to multiply that by 2 because I have 2 of them. So 5 times 5, that's 25 times 2. We have a total of 50 feet squared so far. And then we add to that our sector, and it's pretty obvious. We have that right degree, so it's a 90 degree. That's 1/4 of a circle. So if we're going to take pi times the radius squared, we're going to divide it by 4 because I only want 1/4 of the circle. All right, so 3.14. The radius of this circle would be 5 because the circle would actually continue and go something like that. This is right in the center. The radius is 5. So we got 5 squared, and we're going to divide that by 4. And when you do all that, you end up with 19.625. And so we're going to add those two together, and we get a large number, 69.625, and it's feet, and it's squared, and that's our final answer for the area of this funky shaped garden. Pretty cool. Maybe it goes around the corner of a building, for all I know. But anyway, it is what it is. Ladies and gentlemen, that's it for what we're doing with this lesson, other than the quick write, finding the area of this composite figure. And I would like you to please draw it, mark it down. So you have this triangle here and something else on top, and then write down the dimensions. Notice what they have and where they're putting the marks so you can find the proper areas and add them up to find the total area for this composite figure. Please make sure you put down any questions that you have regarding finding area of composite figures. Bring those questions to class. If you can't think any of off the top of your head now, maybe as you begin working on your assignment, finishing off your 45 quality minutes, that you will come across some questions there that you can certainly ask in front of the class, because I'm sure that if you have a question, more people have questions as well. Be aggressive. Use some urgency to get your assignment done. Attitude and effort, they're everything in what you're doing, especially when you're using your time efficiently. Ladies and gentlemen, we'll see you tomorrow.